Hello, everyone. Welcome back to another great week in Mrs. Golding's classroom. I get another great opportunity to do the Friday paper again this week. So, 2 weeks in a row. Hopefully, this week will be even better than last week. So, Mrs. Golding and I went through and did the Friday paper, and we decided the problems we'll be doing are 13, 14, 15, and 17. So, we got to go all the way to number 13 to do our first problem. So a lot of these problems have not a lot of work, but just a lot of description to them. So we're going to be doing hopefully majority of these big ones in class together because we all know this is the last full week until I learn. So we're going to try to get you guys as prepared as possible in these last couple days. So number 13, I think a majority of you guys, we can do this really nicely. So it is just simplify a to the negative ninth times a to the fifth. So when we do this, remember, first off, since we have the same bases, we'll be able to do this rule. So both of the bases are a, and now since we're multiplying these together, what we do is remember we can now add our exponents. So our exponents, sorry, those are kind of some funky looking circles, but we can add our exponents now because we are multiplying by the same base. So nice and easy. Negative 9 plus 5 will give us a to the negative fourth. But remember, we want this simplified all the way out, so we have to give this exponent, make it be positive. And remember how do we make exponents go from negative to positive? Remember, when we do that, all we do is we flip our base. So our base is just a, so if we flip it, it's going to be 1 over a, and then our exponent becomes positive. So 1 over a to the fourth. So that one is pretty straightforward. Again, it tests knowing when we're going to add our exponents and then how to go from a negative exponent to positive exponent. So here, I'm actually going to write this a little bit better. I'm not going to write it like a slash. I'll write it like 1 over a to the positive 4. So that one's pretty straightforward, pretty nice and easy. Good one to start with. So again, number 14, we get find the slope of a line that passes through point A at negative 3, 4, and point B at negative 5, 2. So remember our slope, whenever we have 2 points, A and B, remember it's that big thing. It's whenever we poke at our thing and we rotate our point. So if I'm poking at negative 3, 4, and I turn it, that means 4 is going to go on top. So I'm going to write M because remember M is the letter for our slope. M is equal to, so 4 is going to be on top over a negative 3. And then remember it's minus, minus. Do the same thing with B. I twist, or I poke and I twist it. So that means 2 goes up top and negative 5 goes on bottom. So remember, it's minus a negative on the bottom. Don't just think because I have one negative sign, I'm done. So on the top, it's 4 minus 2, which easy peasy is 2. And the bottom is negative 3 minus a negative 5. So I always like to go positive, positive. And that ends up being negative 3 plus 5, which is 2. Easy enough. 2 over 2 reduces to 1. So our slope for this problem is just little old 1. Again, nice and easy. Good one right here. So hey, number 15. Number 15 might look really easy, but it would be really easy to mess up on because we don't do everything in the correct order. So it's what is the value of the expression? And we have this big old thing. So it's negative 8 plus 4 minus 7 plus 9 minus 2 plus a negative 5. So remember, order of operations are grouping. There's no grouping besides our negative 5, but remember it's in there by itself, so it's just negative 5. There's no exponents. There's no multiplication or division. So now we just do adding and subtracting. So remember, when we have adding, subtracting, or even multiplication and division, we go from left. It looks like I'm on right on the screen, but my left to my right. So that might look backwards for you guys. So I'll go this way for you guys. Here and across. Left to right. So I look at my very first one, and it's just negative 8 plus 4. So what I'm going to do, I'm going to do negative 8 plus 4. So that's going to be negative 4. Then I'm going to write my next one down. So minus 7. So negative 4 minus 7 would give me negative 11. I'm going to write my next one, plus 9. Negative 11 plus 9 is going to give me a negative 2 and then minus 2. So that's going to give me a negative 4. And then it's plus a negative 5. So that would just be the same thing as negative 4 minus 5. And so negative 4 minus 5 is negative 9. So notice how I went. I did my first two. I did that, and I got this. I did negative 8 plus 4. I got negative 4. And then I kept going from left to right. So then I did minus 7. Then I got to negative 11. Plus 9. And then I got negative 2. So then negative 2 minus 2 is negative 4. And then plus a negative 5. So this one's just really honestly keeping organized and making sure you go all the way from left to right. So number 15 is negative 9. So there's 3 problems right there. And we got one more for you guys. And it's actually number 17. So if I get a scroll, choose all rational numbers that apply. So looking at this, the way how, remember when we write rational numbers means these numbers aren't, how am I going to say this? They don't go on forever at randomness. So like we can always write rational numbers either as just a regular whole number, we can write them as decimals, or we can write them as fractions. So I always try to think about those. So right off the bat, nice and easy. Let's do a different color besides black. How about this blue? I like blue. So rational encompasses every type of number besides irrational. So let's see what we get. So all rational numbers is 13 rational. I would say, yeah, because it's a whole number, right? We can write that. Negative 5 over 6. Well, or negative 5.6. Yeah, that's rational because we can write it, right? It goes on forever. Or it doesn't go on forever, excuse me. 3 over 4. So 3/4, I can also write that as a fraction, like because it is a fraction, and then I can write it as a decimal too. So that one also works. 15%. Now that's not in a normal fashion, but we can also write that as what? 0.15. Oh man, I wrote a really big 0. 0.15. And that's just written as a decimal, so that works. Root, or the square root of 34. So is 34 a perfect square? Well, I know 36 is. So that means 34 is not a perfect square. So that means it's decimal. Because if you were to check this when you're done, you would see on like if you did square root of this on a calculator, it would be like 5.9 something. It would just keep going on and on and on. And it would technically never stop. Well, that is what an irrational number is. So we do not pick E. E is irrational. And then lastly, so F, how can I rewrite square root of 81? I can actually rewrite that, we all know, as 9, because the square root of 81 is 9. And that's just like A, so this is a rational number. So all of these answers work besides E. So again, here's 17. I know you guys, if you wanted to look at these again, you would have paused it, but I'll scroll back up to look at 13, 14, and 15. If you guys need to pause it and glance at that, do that. But that is all the problems we're going to have on the video. So we'll be going through a lot of these throughout the week. So if you guys have any questions about these, come in with them tomorrow and we can review them. But if not, hope you guys have a great rest of your day and see you this week.